Today we are doing section 1.5, day 2, solving absolute value inequalities. Our objective is to solve inequalities containing absolute values. So basically we're taking everything we've done this week and putting it all together into one type of problem. Doesn't that sound like fun? Absolute value inequalities. If the inequality contains greater than or equal to, then we rewrite the inequality as a compound inequality containing or. Okay, so one helpful mnemonic is think more is or. The other is to think of it as greater. You know, usually we say greater, but greater. Okay. So this is just saying how we split it up. If the absolute value of x is greater than k, whatever that is, then we split it into two problems. X is greater than k, or x is less than negative k. So notice we switched the sign on k, but what else did we do? To the inequality symbol, we flipped it around, we switched it. Okay, so we'll see that in action in just a moment. All right, here's our first problem. We have an absolute value inequality using a greater than symbol. So we know we're going to change this into a compound inequality using the word or. Just like yesterday, our first step is going to be to make sure the absolute value bars are alone. Are they alone? Yeah. Yes, they are. So we are ready to split it up. A lot like yesterday, one of our problems will be the exact same problem rewritten without the absolute value bars. So 2x minus 3 is greater than 7. For our other inequality that we have to set up, we keep what was in the bars the same, so it's still 2x minus 3. We have to flip this inequality symbol around, and we change this 7 to its opposite of negative 7, and we would put the word or in between these. That's what it means by changing it into an or compound inequality. Good. Our next step is to just solve these like we would have earlier this week. So we add 3 to both sides. 2x is greater than 10. Then, wonderful. X is greater than 5. Very good. Okay, or we have to solve this one also. Still adding the 3. Wonderful. Divide by 2. X is less than negative 2. Very good. Okay, so our last part is to graph it on a number line. Graphing or inequalities is the easier one because we don't have to worry about an overlap. We just have to worry about graphing both of them on the same number line. I'm going to count by 2s. If you want to count by 1s, that's fine. All right. Let's start with the inequality on the left. Do I want an open or closed circle at 5? Open. Open at 5, which is going to be between 4 and 6.
Shaded to the right.
Shaded to the right. Very good. Okay, we still have to graph the other half of this problem, which is x is less than negative 2. Open or closed at negative 2?
Open.
Open and shaded to the left. So we have open on both of them because neither of them had the equal to bar. And we shade whichever way we are told to. Okay, number 2. Are the bars alone?
Yeah.
Yes, so we are ready to Split it up. Who can tell me what one of them would be? Q.
2x minus 5 is more than 3.
Wonderful. 2x minus 5 is more than or greater than 3. And the other one, Charles?
2x minus 5 is less than -3.
Perfect. And what word belongs in the middle here?
Or.
Or. These are or inequalities because we started out with a greater than symbol. Okay, now we are ready to solve. You're skipping ahead of us. Okay, let's solve them. What am I going to do? Add 5. I have 2x is greater than 8.
Divide by 2.
And we get x is greater than 4. Beautiful.
How did you get to
All right, on the other half of it, what do we do to solve? Wonderful. This time we have 2x's less than 2. Then x is less than 1. Again, we still have what word in between them? An or. Okay, now we are ready to graph them.
Can you go by 2?
If you want to. I'm going to go by ones, but if you want to go by twos, you go for it. Open or closed at 4? Open at 4, shaded to the right. I agree. Not a whole lot of shading on the number line I drew. Okay, and then what about at 1? Open, shaded to the left. Yes, and then we can start singing Beyonce.
You know who Beyonce is?
Yeah.
Ideas on what we should do first. Anybody new? Oh, or everybody at the same time. Subtract 6 from both sides. I like it. We need the bars to be alone. Can I go ahead and distribute that too? No, we're not going to do that with the bars. So what are we going to do with it instead? Divide the 2. I am writing way too big for this. 4x minus 1 is greater than or equal to 7. Okay, so I am going to create more space for myself. We finished the first part of isolating the absolute value bars, so I will rewrite it at the top to continue solving this problem.
4x minus 1 is less than or equal to 7.
Greater than or equal to 7? All right. Now that the bars are isolated, we are ready to
solve?
No. Split it up. Somebody I haven't heard from yet today. Tell me what one of my problems would be. Emily. Yep. No, you're right. Greater than or equal to 7. Very good. Somebody else new, tell me my other one. Less than or equal. Very good. Okay, so our other one would be 4x minus 1 is less than or equal to negative 7. So again, we flip the inequality symbol and we change the sign. Now we need to solve them. To solve, we're going to add the 1. 4x is greater than or equal to 8, and then so x is good. Oh, one thing we haven't done yet on this problem that we should have done. We forgot to write the or, which isn't really going to matter until we graph, but we should keep in mind that it is an or. Thank you, Q, for catching my typo of sorts. So, whoop, wrong color. It's supposed to be a 2. We said it and we wrote the wrong thing.
Our channel.
All right, to solve the other one, we follow the same steps, but we're working with a different number. So 4x is less than or equal to -6. Then we divide by 4. We have x is, so we could keep it as -6/4. If we simplify it, it would be -3/2. If you divide it, it's -1.5. So this is going to be the easiest one to graph. Remember, if a decimal terminates, meaning it doesn't go on forever, we're not rounding it, I'm fine with a decimal. So since it will be easier to graph that one, we'll leave it there. Again, this is still an OR inequality, so when we go to graph it, we just graph them both on the same number line. I am going to count by ones. No, there's no real reason I changed colors. Okay. At 2, open or closed? Closed, because we have the equal to bar on these. And we are going to shade it to the right. All right, and then on -1.5, where is that going to be?
That's going to be like a little after the
No, a little after the 0.
A little after the 0?
Oh, -1.
Oh, I kept
After the.
Very good. It's going to be between -1 and -2.
Oh, I had kept it at -6. I'm going to say a little after the 6.
Yeah, we gotta divide that 4. And which way would we shade?
You'll shade to the left.
To the left. Questions, concerns?
That would.
All right, if the inequality contains a less than symbol or a less than or equal to symbol, then rewrite the inequality as a compound inequality containing and. Okay, one way to remember it is less is nest, because the variable gets nestled or nested in between the two sides. The other way to think about it is less than and. Okay, kind of make a new hybrid word out of it. First things first, are the bars alone?
No.
No, we need to
Add the side to the left side.
add the 7.
It was 44. Greater than 44.
So the absolute value of 5z plus 3
It's less than 41.
is less than 41. Okay, then we need to
Makes it 2 problems.
Okay. We can split it up into 2 problems, or we can create one big long problem. Remember when we had them like smushed in the middle? Do you remember doing that, where you do it to all 3 pieces?
Oh, yeah.
So we can do that with these because they are and inequalities. So part of the problem is going to be 5z plus 3 is less than 41. What do you think is going to go on the other side?
Same thing.
Kind of the same thing, but it's flipped around and the 41 is negative. That's way smaller.
Oh, I see.
Alright, whatever we do to get z alone in the middle, we have to do to the outer parts also. So what am I going to do?
Subtract 3.
Subtract 3 from the middle and from both sides. So we end up with a negative 44 is less than 5z is less than 38. And then we have to divide by 5. These do not come out pretty, so I would leave them as improper fractions. You could change them into decimals. They should terminate. They just aren't super pretty. Less than z less than 38 fifths. So if it's easier to use decimals to graph it, go ahead and do that. Did anybody get the decimal form for negative 44 over 5? No. You don't have to use decimals. I just thought it might be easier if you do.
8.8.
Negative 8.8?
Yep.
Okay. And then what about for 38 fifths?
7.6.
7.6. Okay, so if it helps for your point placement to do that, go ahead. Again, you don't have to. I probably should have counted by twos. Let's go back and do that. 2, 4, 6, 8. Oh, you are correct. So let me just wipe out a lot of this. Definitely going to count by twos. Okay. 0, negative 2, negative 4, negative 6, negative 8. All the way down here is going to be my negative 10. This is probably one of the worst number lines I've made in a really long time. I'm a little embarrassed. All right, but we are ready to graph at the negative 8.8. Do I want open or closed?
Open.
Open. So negative 8.8 is going to be after the negative 8. What about at the 7.6?
Close to 8.
Close to 8. Is it going to be open or closed?
Close or open?
Open. So pretty close to my 8, but open. And where am I shading on this one?
In the middle.
In the middle. So there's a lot to shade here. All the way down the middle.